Little bit of information on the sort of projects that we do. Our large air traffic control application has already been mentioned. That's a system called IFACTS, which stands for Interim Future Air Control Tools Support. I'm glad I don't design the acronyms. Essentially what this is it's a set of support tools for air traffic controllers. Certainly in the UK, I think the state of the art worldwide at the moment is that air traffic controllers have a lot of information in their heads. And that's something that they are required and selected and trained to manage. IFACTS is a system to give them some support in that. It can predict the trajectories of aircraft over a much longer time scale than is easy to do in your head. It can use those predictions to detect potential conflicts between aircraft. And it can monitor that aircraft are behaving in reasonable accordance with the air traffic controller's expectations on the basis of the flight plan. It's being delivered, IFACTS is being delivered by a joint team including Praxis and the client, who are the UK's National Air Traffic Services, NATS. And it's a safety critical system. It's being certified to the UK standard SW01, which if you're a fan of international air traffic control software standards is the UK analogue of ESA RR6 in the US. And that is essentially a full safety delivery, full safety case delivery alongside the software. Going back a little bit further, just to show some history really, another project that we used Spark on, and we used Correctness by Construction on, was a system called Sholis, which is essentially a landing aid for helicopters trying to acquire relatively small spaces on the back of ships. It was in its day the first ever project delivered to the UK's current military standard at the time, which was a thing called Interim Def Stand 00055, which again, connoisseurs of standards will know was a pretty stringent and rigorous set of constraints. We specified the system formally in the Z notation. We wrote the software in Spark. We did elements of formal proof at both the specification and the implementation levels, and actually got some very satisfying results about the effectiveness of proof and the effectiveness of these rigorous and formal techniques. And some metrics which I think are comparable with general industry standards, in spite of the fact that we were using these horrendous and very expensive mathematical techniques. That's all well and good. That's where we're coming from. But what I like to do is to link these back to today's topic, which is really lean. I'm a little bit cautious about starting to talk about lean principles when I'm following eminent speakers like this morning. And fortunately, and without prior consultation, I've got the same aim list of lean principles as everyone else. And I've got some wording from there which I have taken from Professor Merman at MIT, I think, and the Lean Aerospace Initiative. What we're really talking about is how we get value, how we generate that value through the value stream and elimination of waste, how we can make that stream flow, eliminate gaps, operate in response to the customers, while simultaneously pursuing improvement and perfection. I'm just going to pick up really on slightly more detail on the first three of those, because they are key to the examples that I'm going to come to in just a moment. Value. The emphasis on value in Lean, we think ties across very well to our long-standing commitment to requirements and to understanding what the customer's real need is and the real objectives of the program are. Just an example of this. It's possible when you're scoping, say, an independent verification validation activity, which is something that we do fairly frequently, to get caught into the trap of believing that what the customer is interested in are the deliverables of your project. And they're going to be plans, and they're going to be test specs, and they're going to be process documents, and they're going to be results documents. Actually, no. If the customer is a software developer and he's hiring you to do some independent V&V, what he's probably interested in are the things that cause changes to his product. He's interested in the bug reports. And so if your project doesn't take that into account, you're probably going to be heading in the wrong direction. I mean, of course, speaking here at an event hosted by a compiler vendor, the whole idea that the error messages are much more important than the object code because programmers spend much longer looking at the error messages is a standing joke in the software community. And being aware that I was going to be in the slot immediately after lunch, I felt the need to try and find some humour. So without any endorsement or criticism of the firm whose name appears on the following image, I found my favourite error messages. If you can't read that at the back, that actually says, test cannot be started because it already does not exist. This is not a professional commitment, but I personally use AVG on all my any Windows machine I use, but that error message I did find, and it did confuse me. Second principle is the elimination of waste, anything that doesn't contribute to the value. I think it's interesting to go back to the Japanese production philosophy on waste, because it seems to cast the net rather wider than some of the, scare quotes, lean initiatives that we've seen. It's not only obvious things like delay and rework and nugatory work, but some of the original work seems to pick up on overstretch, overload of a resource as being a form of waste. It's something that's not right in the way that the process is working. And there are a number of tools that we can use to identify and eliminate waste. We can draw product breakdown structures. We can do left-to-right planning. And at this point, of course, you'll hopefully start to see that the whole correctness by construction principles, taking small steps, verifying small steps, capturing the correctness of those small steps as we go along, is really trying to eliminate waste. It's trying to eliminate rework, eliminate backflow. Again, a concrete example here. I was involved in replanning of a major railway upgrade program, which essentially sat down and over the course of a couple of days, just by chasing through dependencies and looking at the value flow, took about 30% out of the estimated design budget of that plan. And that was an 8-figure euro change to the plan through the application of that principle. Final principle I'm going to touch on here is flow. The idea that processes where there's a dependency are going to be limited by the slowest is fairly standard, and there are a whole bunch of techniques which many people here are more qualified than I am, probably to talk about how we address that. But again, this is the after lunch slot, and there'd been some discussion of Kanban this morning, and one of my colleagues, David Johnston, came up with a marvellous Kanban, the idea of a token that generates the solution to a problem. The problem that he took as our group administrator was, in fact, supplying the operations department with the appropriate combinations of tea and coffee and the appropriate additives. That is the ops bay tea tray, and it has a photograph of everyone who sits in the bay, along with identifying information about what drinks they prefer and how they prefer to take them.